Welcome back, everyone. In this part, we'll focus on writing the deployment script and test cases, and then deploy our DEX contract to the network. This is where we verify the logic, test real scenarios, and bring the exchange fully to life. So let's get started. Now we'll go on writing our script. So in script, we'll create a file and we'll name it as Deploy.s.sol. In this, we'll write a deployment script. So the script will automate the deployment of DEX and mock tokens. We'll also create a liquidity pool and add initial liquidity, making setup quick and quite repeatable. Now first, let's give our license identifier, then pragma solidity 0.819, and we'll go for importing now. So importing, we're first importing script. We're importing this from for RSKDex.t.sol. This will import the Foundry script utilities and console login. Then import RSKDex.t.sol. RSKDex.t.sol. So it will be importing our RSKDex smart contract. Then we'll be importing another smart contract as well. Mock ERC from SRC, then from mock SRC. I imported all of these. Now we'll go on writing our contract. We'll give contract deploy script, name it as deploy script. The main deployment function which will be there, which will be executed by for. So we'll give for function run public, and then we'll give RSKDex. Dex is equal to new RSKDex. So we'll be deploying the RSKDex contract. Then console.log RSKDex deployed at RSKDex deployed at and the address of the DEX. So it will log the deployed DEX address. Then mock ERC20 token A would be equal to new mock ERC20 token, and will be given by the name as TKK. So this will deploy the mock ERC20 token A. Similarly, we'll be doing it for B as well. So token B, and here also into token B, and we'll give the symbol as TKB, both mock ERC20 token A and token B. Now again console.log, and we'll give the token addresses of A and B. So token A is deployed at and will give the address of token A. So address token A. Similarly, we'll be displaying the token B's address. So token B is deployed at, so we'll give console.log token B deployed at and the address of token B. Now we'll go on creating a liquidity pool. So bytes 32 pool ID, that would be equal to DEX address of token A, also the address of token B. So it has just created a liquidity pool for both token A and token B. And now console.log, and I'll give display pool created with ID, and for the ID we'll be giving the pool ID here 1256 pool IDs pool ID. Now we'll go for initializing and defining the initial liquidity amounts. So initial amount A, we'll give it as 1 million into, so it is 10 decimals. So we'll give here, 18 decimals. So we'll mention 18 here. And similarly, we'll be initializing the amount for B as well. So here you want 256 initial amount of B. And the same. We have defined this initial liquidity amount, that is 1 million tokens for each token A and token B. Token A dot and the address of DEX and the initial amount of A. This will approve DEX to spend token A. Similarly, we'll be approving DEX to spend token B. So token B dot approve the address of DEX and the initial amount of B. Now we'll add the initial liquidity to the pool. So you want 256 actual amount A, you want 256 actual amount B, and the liquidity. And this would be equal to DEX liquidity equal to DEX dot add liquidity, and we'll have the pool ID, the initial amount of A, initial amount of A, initial amount of B, then we'll be giving 0. So this 0 is for the minimum token A. There is no slippage protection. Then 0. This first 0 was for token A, second was for token B. Message dot sender. And now we'll give the log liquidity addition details. So console dot log the initial, so give it as initial liquidity added, then console dot and token A amount that would be actual amount. Similarly, we'll display token B's amount as well as the liquidity tokens. So here we'll give the token B amount, actual amount of B. And here we'll be giving liquidity tokens. So liquidity tokens that would give the liquidity amount. This will display the liquidity. Now we'll be printing the complete deployment summary. So console dot and we'll give here the deployment summary, or we'll start it on a new line, \n the deployer summary. We'll give it as deployment summary. Then on the next line we'll begin console dot log and the deployer and the message dot sender, which is the deployer. And then we'll be displaying the RSKDex. So we'll be displaying the address of the RSKDex. So we'll give here as RSKDex and the address of RSKDex.txt. We also have to go on printing the address of token A, address of token B, and the pool ID. Token A address, similarly token B, and the address of token B. And here in this will be showcasing the pool ID and the address of the pool. And to showcase this pool ID, we'll give event 456 the pool ID. Now we'll go on fetching the current pool reserves. So event 250 and this would be equal to dex.get reserves the pool ID. So we are just fetch the current pool reserves. Now we'll go for logging the initial reserves, displaying them. Console.log initial reserves, initial reserve, console. That's a token A reserve, and this will get the reserve A. Similarly, we'll be doing it for token B as well. So token B reserve and a reserve B. Now we'll go on deploying only the DEX contract with no tokens, no pooled function. We'll create a function and we'll give the name as Deploy.s only. I will publicly give it. So public RSKDex that is equal to new RSKDex, and then console dot log, and here will be now displaying the new address where the RSKDex is deployed. So RSKDex deployed at address of DEX, and then we'll be deploying only mock or ERC20 tokens. So we'll give function deploy mock tokens. We'll give this publicly. So mock ERC20A, and this will be equal to the new mock ERC20 token, and we'll name it as token A, and we'll give it a symbol as B. We'll do it for B as well. So yeah, mock ERC20 token B, and we'll also will name it as token B, and we'll give it a symbol as B. Then we'll create a function as create pool. Then we'll give the DEX address here. Also, we'll give the address of token A and the address of token B. So this creating a pool that has been done using already deployed contracts. Then we'll give it public and we'll connect it to the existing Dell. Right? So RSK Dex is equal to the DEX address. Now we'll be creating a pool bytes 32 pool ID equal to, and we'll have token A and token B. Now we'll just log pool ID. So console pool created with ID, and here we'll give the vm dot toString pool ID. That's it. This was a complete script, a deployment script. So this is a Foundry deployment script that is automating the process of deploying the DEX and mock tokens, creating a liquidity pool and adding the initial liquidity. It simplifies local and testnet deployment while logging the contract addresses, pool details, making it quite easy to verify successful setup and interact with the DEX after deployment. Now let's go on writing our test file. So here in this test folder, we'll be creating one file and we'll be naming it as RSKDex.t.sol. So in this file, we'll be writing our tests. So this file will contain all the automated tests that are written with Foundry to validate the DEX functionality. It will also ensure that there's a pool, liquidity, and swap that are working correctly and quite securely. So let's uh, declare the license of the contract. So it's pretty expensive. This identifier. Then Dogma solidity 0.8.19. Now we'll go on importing. So import test, import x, and we'll be importing this from forge cd test dot. So this will import the Foundry test contract which provides testing utilities. Now we'll be importing RSKDex. So here we are importing our main contract. So we'll be importing it from SR. Then we'll be importing another contract that we have written in mock. That is mock ERC. So the address from where we have written mock ERC20 is SRC. In SRC we have made another folder as mock, and inside mock we have a contract as mock ERC20. Now we'll create a test contract and we'll name it as RSKDex.t.sol. So this contract will inherit from the Foundry's test contract. So RSKDex public dex, so it will an instance of the test contract. Now we'll have token A and B. So mock ERC20 public token A and mock ERC20 public token B. So these are the mock tokens that will be traded on the DEX. Then address public. So this is an address of user 1. So address 0x1. So here the user 1 address will be given. Similarly, we'll have second user address public user 2 that would be equal to address 0x2. So these are test user addresses. Then bytes 32 ID. This is an identifier for the liquidity pool. Function setup public. This is setup that will run before each test. Then dex equal to new RSKDex. This is the deploying of a new fresh dex contract. Then we'll be going on deploying two mock ERC20 tokens. The token A is equal to new mock ERC20 and name it as token A and we'll symbol it as TK. Similarly, we'll be deploying for another B and we'll name it as token B and we'll give it a symbol as TKB. Now we'll be going on creating a liquidity pool for token A and B. So pool ID is equal to dex.createPool, address of token A, address of token B, then token dot mint user, and 1 million tokens will be giving with 18 decimals. Mock ERC20 have 18 decimals. So we are minting large amount of tokens to user 1. That is how many? 1 million amount of tokens. So even token A, token B both are minting to user 1. Similarly, we'll be minting this for user 2 as well. Now we'll create a function named as test create pool. This will be testing whether the pool creation works correctly or not. Now bytes 32 expected pool ID that is equal to dex.getPool ID and the address of token A and the address of token B. Address token B. This is calculating the expected pool ID. Then assert equation and inside this will give the pool ID and the expected pool ID. This will check if the return pool ID matches the expected pool ID or not. Then assert true dot pool ID. This will ensure that the pool exists index. Then another function create pool with identical tokens. Public. So this will test that creating a pool with the same tokens reverts. VM dot set revert identical tokens. Identical tokens. So this will expect the transaction to revert with this message as identical tokens. Then text dot create pool. It will have the address of both token A and B, token A, and then the address of token B. And this will attempt to create an invalid pool. If we mention both of token A here, it will attempt to create an invalid pool. Then we'll go on creating another function as test create with 0 address. Let's create pool with 0 address, and we'll make this public. So this will test that the 0 address token is not allowed. VM dot revert and give the message as 0 address. It will expect revert due to 0 address. Then dex dot create pool address 0 token valid and address of token A. So this will try creating a pool with 0 address. Now another function as test liquidity. This will start acting as user 1 now. UN 256 amount A that is equal to 1000 into 10 and 18. So similarly we'll do it for amount B now. B that would be equal to 2000. So we are doing this just like add the amounts of token. Now for approving, like token A dot and address of DEX amount A and token B dot address of DEX amount B. This will approve the DEX to spend the tokens. Then we'll add liquidity to the pool now. So UN 56, the actual amount of A, UN 256, actual amount B, and the liquidity. This will be equal to DEX dot add liquidity and the pool ID, amount A, amount B, zeros, and user 1. Now we'll give assert equation. Assert equations. This will ensure that the exact amounts were used. So actual amount A and amount A. We'll do it for B as well. So assert equation actual amount of B and amount B. Then after this we'll give assert GT. So assert GT and liquidity 0. This will see the liquidity token should be greater than 0. Then we fetch the pool reserves. UN 256 reserve A, UN 250 that's equal to dex.get reserve, the pool ID. Then we'll give her the assert equations for reserve A and amount A and amount B. So this will check the reserve matches added amount. Now we'll just stop impersonating user 1. So for that, we'll give VM stop rank user 1. Now we'll create a function as test add liquidity with ratio public. So this will create a test liquidity addition while maintaining all the token ratio. Start rank user 1, and now we'll initial the liquidity as still amount of A. That would be equal to, as I mentioned above, then initial amount for B, that would be 2000. So we are gonna fill the liquidity. Now we'll go for approving. So token address of X and the initial amount A, token be approved, address of X and the initial amount B. Now we'll go on DEX.add liquidity. So this will first, or this will be the first liquidity provider that will set the ratio. So pool ID, initial amount A, initial amount B, 00 and user 1. Now second user will add the liquidity. We'll start VM start rank and user 2. So UN 256 amount A, that is equal to 500, and we'll go for setting the amount for B as well. That will be 2000. Then again same token A up to, so token A will be giving this same, but here instead of initial amount we'll be just giving the amount of A here for the first, and here below we'll be just giving the amount of B. Now we'll give here UN to A and actual amount of B. This DEX should only accept the tokens according to the ratios only. So this will be equal to DEX dot add liquidity pool ID, amount A, amount B, 00, and here will be the user 2 now, actual amount of A and amount of A. This is a token A is fully accepted, and now we'll be adjusting the token B. The token B, actual amount B and amount A into 2. So here we are adjusting token B to maintain a ratio of 1:2. And here we'll stop this. We have stop rank. Now we'll just test the swapping token. For this, we'll create a function as test swap, and we'll do it publicly. And we'll start this again for user 1 now. Similarly, we'll go for initializing the liquidity for both A and B. Amount A, that equal to 1000, and similarly we'll do it for B as well. We'll keep the same 1000 only. Now we'll go on approving. Same similarly here. Add liquidity, amount A, amount B, 00, and user 1. We'll stop the prank here. So we'll do just 200 and 18, and we'll now calculate the expected output. So expected out, that's equal to dex dot get amount out, and we'll give it here swap amount, amount B. We're just swapping this amount. Then token A dot swap account. I will balance it before swapping. So we went to 56. balance before balance of A. First we'll see balance of B. Balance of B before, that is equal to token B dot balance of user 2 balance of user 2. Now we'll just go on executing the swap. So you went to fit out, that's equal to dex dot pool ID, then the address of token A, address of token A, address is done, then swap amount 0 and the user 2. Now we'll balance it after swap. So UN 256 balance B after, that is equal to token B dot balance of user 2, then assert new amount out and expected amount. This will verify the output amount, whether the amount out matches the expected one or not. Then we'll give again, this will be for ensuring that the balance is increased correctly. So balance B after minus balance B before has amount out. And assert LT amount out at swap amount. So this will be the amount. Output should be less than input due to the P. Then VM dot stop rank. Now we'll go for creating another function to test without test swap without the liquidity, insufficient liquidity, that is public, and we'll start it for user 1. So VM dot start rank user 1, then uint 256 swap amount, that's equal to 100 into 10, no, 18.1. Token A dot address and swap amount. Then we'll go for reverting it. So VM dot expect revert, expect revert, insufficient liquidity, insufficient liquidity. So this is an expert revert because the pool has no liquidity. And DEX dot pool ID, address of token A, swap amount 0, and user 1. Then we'll stop it here. VM dot stop rank. And now another function that we'll be creating is your function test swap insufficient output. Test swap insufficient output. So this test swap will be failing due to high minimum output. So it's for that public, and then we'll start it for user 1. uint 256 amount A equal to 1018, and uint 256 amount B, that's equal to the same. Then token A and token B approved. So token address of DEX and amount A, same for B as dot approve, address of DEX and amount of B. Now we'll give DEX dot add liquidity, DEX dot add liquidity, then the pool ID, amount A, amount B, 001. Now we'll go for swap amount, that would be equal to 100, and then we'll give an unrealistic amount, unrealistic min out. That would be equal to 200. This then with 18 decimal. Then token will have the address of DEX and the swap amount. Swap amount. Then we'll expect a revert. So VM revert, and it will display a message as insufficient output amount. This is an export required due to slippage protection. Then DEX dot which will have the pool ID, address of token A, then the swap amount, the one which we declared here, the unrealistic min out, and the user one. Then we'll stop the rank, and now we'll create a removal liquidity function. That's a test to remove the liquidity function. Let's name it as test remove liquidity public. This will start it for user one now. Start the user one. I will give the UN 256 amount A. So we'll give the amount for A as well as B. Amount that would be equal to 1000 and plus 80. Similarly, we'll give the same for B as well. We'll set the same amount for B. This will write here amount. And then now we'll go on adding the liquidity. So UN 256 liquidity that is equal to DEX dot add liquidity, the pool ID, amount A, amount B, amount A, amount B, 00. This was for slippage and user one. Now we'll remove half the liquidity which is there. So for that UN 256 liquidity to remove, we'll give it as liquidity to remove. That is equal to liquidity by 2, because we're removing half of the liquidity. Then UN 256 will have see the balance of A before and balance of B before. So for seeing balance of A before, token A dot balance of user one, as we have started it for user one. Similarly, we'll check the balance of B before, balance of B before, and the token B dot balance of user one. Now let's go on removing the liquidity. This will give you in 256 amount out, amount A out, B out. This would be equal to X dot remove liquidity, pool ID, liquidity to remove 00 user one. So we have removed the liquidity, and now we'll verify the returned token balances. So assert EQ token A dot balance of user one, balance of minus the balance of A before, that will be same will be for B. So assert EQ token of B, balance of user one minus balance of B before, that will give us the amount of B out. Then we'll be approximating the half returned. So assert approx EQREL, that will give a amount of A out, that is amount of A by 2, that is about 0.01 E18, and we'll here VM dot. Now we'll go for creating a new function. This function will be a test swap or an output calculation logic. So this is a test get amount out. We'll name it as test get amount out. as will be public. Now this will give the variables as amount in and will define this as 100. Similarly, we'll give more two variables that would be a reserve in and reserve out. Reserve in and this would be reserve out. So this values will make it as 1000 for reserve in and reserve out. Then UN 256 will have the amount out as well. This would be equal to Dexter get amount out, the amount in, the in, reserve in and the reserve out. Now to make the output to be positive and greater than 0, we'll give assert GT amount out, 0. So this will make sure that output is greater than 0 and is positive. That's now assert LT. This one is to make sure that the output is less than the input. Amount out is less than the input amount. Then we'll create another function and name it as test get user liquidity. Test get user liquidity. So this is a test for tracking the user's liquidity. It's public. It started for user 1 now. em dot for user 1. I will create amount A that is equal to 1000 into 1080. Similarly, we'll have it for B as well. So we'll make this for amount B. And I will go on adding the liquidity. Or liquidity that's equal to DEX dot add liquidity. And we'll have the pool ID, amount A, amount B, amount A, amount B. Though to prevent slippage, we have 0 and user 1. And we'll verify the liquidity ownership. So this will have assert EQ. And this will write DEX dot get user liquidity and the pool ID user 1 and the liquidity here will be verified. Ownership of the liquidity will be verified, and then again assert EQ DEX dot get user liquidity, the pool ID user 2, and now we'll give it to 0, showing that user 2 has no liquidity. And we'll stop it here. VM dot stop rank. That's it. That was all about our test file that we have created. That's RSKDex.t.sol. This is containing all the automated tests that are written using Foundry to verify all the correctness of the test. So it tests the pool creation, liquidity addition, removal, token swaps, the slippage protection, calculations, failure scenarios, and this test ensures that the marked contract behave securely and predictably under both normal and edge case conditions. So we'll be creating a file named .env in which we'll be securely storing our sensitive configuration values like the private keys, RPC URLs, API keys outside the source code. So in that you just write private underscore key is equal to and just paste your private key there. Now we'll go on opening our terminal. So in terminal, we'll first export our private key. So export private key is equal to 0x and just paste a private key. Add this confidential. I won't show it. Then we'll give cd and we'll just redirect it. And then next command that will give is to deploy the script. Forge script slash the name of the script file, that's Deploy.s.sol, and we'll just mention the RPC URL. It's and the URL what it is, public node dot testnet dot rsk.co, and here also private underscore key broadcast legacy. So we'll just run this now. So this port script command is used to deploy Solidity smart contracts using Foundry. So this first port script Deploy.s.sol, this tells Foundry to run the deploy script contract which is inside the Deploy.s.sol file. Then you have RPC URL that specifies the RPC endpoint of the Rootstock testnet. Then this private key which we have written, that is an option that provides a deployer's wallet private key from an environment variable, keeping it secure and out of the script and terminal history. And we have broadcast that instructs Foundry to actually send the deployment transaction to the network. And legacy just focuses the use of forces the use of legacy transaction. So here we have successfully done the on-chain deployment of our RSKDex project using this Foundry script. So the script ran successfully. So this forge first check the compilation. Now here in logs we can see RSK is deployed at, then we can see token A, token B is deployed at, and we can see their address. Pool is created with this particular ID, and then the initial liquidity which is added to token A, token B, and the liquidity token can be seen under the logs section. Then we have the deployment summary where we have the wallet addresses of deployer, the RSKDex, token A, token B, then we have the complete pool ID and the initial reserves that we have done in token A reserve, token B reserve. Then we have run this using testnet, that's chain 31, and where we have all this transaction that have taken place all over. We can see the hash there, the contract address, and all are successfully transacted using under the block 7204234, paid this much amount of TRBTC for each transaction that has successfully placed. So that's all the execution which is complete and successful. That was all about the video. Thank you.